The Baikonur Cosmodrome, located in the middle of the deserted steppes of Kazakhstan, is the Russian space launch facility used to start the journey towards the International Space Station. It is a huge complex that comprises several technical buildings, some for assembling and preparing the rockets, and others to accommodate the technicians, engineers, and crews. It was from Baikonur that Yuri Gagarin began his extraordinary journey around the Earth more than 50 years ago. Today, every launch of the Soyuz vehicle brings 3 new crew members on board the International Space Station. They prepare for their mission in Star City, the training center of the cosmonauts, located near Moscow. Before stepping onto the launch pad, all the crew members have to undergo hundreds of training hours, both theoretical and practical, to be able to operate and control the Soyuz spacecraft in any situation. The practical part of the training makes use of realistic models of the spacecraft that allow the cosmonauts to feel almost as if they were in a real situation. They all follow the path of many others who flew before them from Baikonur. Let's discover how a Soyuz rocket works. The rocket has a total length of approximately 50 meters and a diameter of up to 10 meters. The total mass is about 310 tons. It consists of 3 parts called stages. A mixture of kerosene and liquid oxygen is used in order to generate the required propulsion. On top of the rocket stands the Soyuz spacecraft itself, encapsulated within the structure of the rocket's nose. On the launch pad, 4 green arms ensure that the rocket is positioned properly before liftoff. The arms will mechanically rotate away to release the rocket while it leaves the ground. The training being successfully completed, the crew members are ready for the launch, and the rocket stands on the launch pad. 2.5 hours before liftoff, the crew finally enter the spacecraft and start preparing it for the launch in collaboration with the ground controllers. They are now set for the launch. The cosmonauts are now sitting on top of 300 tons of propellant. What happens if anything goes wrong? The Soyuz rocket is equipped with a robust and powerful system designed to save the crew in case the rocket were to start burning or explode on the launch pad. This is the Launch Escape Tower. The Launch Escape Tower is itself a small yet powerful rocket made up of several engines which use solid propellant. It's capable of quickly extracting the crew compartments from the rest of the rocket in case of an imminent threat to the crew, like an explosion for instance. The mechanism may be triggered automatically or upon command from the ground controllers. On only one occasion in the history of Russian cosmonautics was this escape system put to use. In September of 1983, while the rocket was ready to lift off to bring 2 Soviet cosmonauts to the Salyut 7 station, a valve failed to close just 90 seconds before final ignition, causing kerosene to spill onto the pad and ignite. Fortunately, it was quickly realized that the crew was endangered and the ground controllers activated the escape system. Explosive bolts fired to separate the crew compartments from the rest of the spacecraft, and the escape motor fired, dragging the crew compartments free of the boosters. Although the 2 crew members experienced an acceleration of 14 to 17 G for 5 seconds, they landed safely on board their capsule some 4 kilometers away from the launch pad. The G-load is a common way to express the acceleration, in other words, the force that the crew may feel during changes in velocity. The 2 cosmonauts, Strekalov and Titov, would go on to fly several highly successful missions in later years. This incident proved how reliable the launch escape system really is. Let's go through the launch sequence now. At T-0, we have liftoff. Full thrust is provided by the 4 side boosters and the central block of the rocket. The core block is ignited at the same time as the 4 boosters to provide an additional thrust. The rocket then initiates a maneuver called the pitch maneuver to get the proper orientation towards the desired orbit. The acceleration on the crew members starts to slowly increase to 1.5 g. 45 seconds later, the rocket has already reached an altitude of 11 kilometers and a velocity of 1,640 kilometers per hour. This is the moment the rocket must withstand the maximum pressure on its structure. The cosmonauts feel twice their normal weight on the ground. Looking at the projection of the track on the ground, we can observe that the rocket has already crossed 16 kilometers. After almost 2 minutes into the flight, the rocket is at an altitude of more than 40 kilometers, high enough to get rid of the launch escape tower. A few seconds later, the 4 strap-on boosters stop firing, having consumed all the propellant they contained. Being of no use now, they are jettisoned from the main core, which continues to fire and is now called the second stage. In case of a severe malfunction at this point, the spacecraft can still separate from the rest of the rocket and come back safely to the ground without the need for additional propulsion. The debris follows a trajectory that leads it to hit the ground in an uninhabited area located more than 350 kilometers from the launch pad. Soon, the crew members will experience the maximum acceleration on their bodies, 3.5 times their own weight, but only for a few seconds. This is the most physically demanding moment for the cosmonauts. In the meantime, the second stage continues to fire for 3 more minutes. The structure that protects the spacecraft is then jettisoned. Once again, the debris will follow a safe trajectory to hit the ground 530 kilometers away from the launch site. The spacecraft is now fully exposed to space. The light from outside can now enter the crew compartment through the small windows. It's now been approximately 5 minutes since liftoff. 2 seconds before the extinction of the second stage, the third stage is ignited. Then the second stage separates from the rest of the rocket. The engine of the third stage will continue firing for the next 4 minutes. As with the 4 boosters, the second stage follows a safe trajectory down to Earth. The rocket is already at an altitude of 170 kilometers and traveling at a velocity of 13,250 kilometers per hour. Then, the circular section that links the second stage with the third stage is jettisoned, while the rocket goes on to reach the targeted orbit around 220 kilometers above the surface of the Earth. Once on the desired orbit, approximately 9 minutes into the launch, the last engine is cut off. The spacecraft finally separates from the rocket. The cosmonauts can now feel the microgravity. Moments later, the antennas and the solar arrays are deployed. The spacecraft is now on its way to the International Space Station.